So welcome back coders. In this video, we will be discussing the question merge two sorted linked list. So let's discuss the question. So we've been given two sorted linked list. Our one linked list is 10, 20, 30, 40 and 50. Our other linked list is 7, 9, 12, 15, 37, 43, 44, 48, 52 and 56. So in this question, we have to merge both these linked lists. So, and the resultant linked list will also be sorted. So first of all, 7 will be added, then 9, then 10, then 12, 15, 20, 30, 37, 40, 43, 44, 48, then 50, 52 and 56. So what we'll do is, we will create a new linked list. We won't be changing anything to the given linked list. We will make a new linked list and we'll add at last. So try to do this question on your own and we'll discuss the solution in the next part of this video. I hope you tried it on your own. So let's discuss the solution of this video. So let's assume that we have been given two linked lists that are sorted. So what we'll do is, we'll get a node which will be on the head of our first linked list. We'll get another node which will be at our head of second linked list. Now what we'll do is, we'll just compare which one is smaller. So if in 7 and 2, 7 is smaller, so we'll add 7 to our resultant linked list. Now we'll just move our pointer ahead. Our 2 will come here. We'll again check whether 9 and 10, so 9 is smaller. We again move 2 ahead. It will come at 12. Again we compare. Now 10 is smaller, so 10 is added. Now we move this pointer. This moves ahead. Among 12 and 20, 12 is smaller. Now we move this at 15. Again 15 is smaller. We move this at 37. Now 20 is smaller. We move this at 30. 30 is smaller. Then again we move this at 40. So now 37 is smaller. Now our linked list is empty. Our 2 is pointing at null. So now what we'll do is, we'll just add all the data that are left in the first linked list. We'll add 40 and we'll add 50. So this is the basic concept of this question. Now let's try to code this. What we'll do is, we'll just have to write a code for merge two sorted linked list. So first of all, we'll create a node 1, which will be at L1.head, head of the first linked list. We'll create second node, node 2, which will be at the head of the second linked list. Now we'll create a new linked list. Linked list named result, new linked list. Now what we'll do is, while both the linked list have elements, so while 1 is not equals to null and also our 2 is not equals to null, we'll just compare both the elements. If 1.data is smaller than 2.data, then we'll add 1.data in the result. So we'll add last 1.data. And what we'll do is, we'll just move our 1 step forward. If this is not true, then we'll just add 2.data. And we'll move our 2 at 2.next. Now, if one of our linked list has already ended, if 1 is not equals to null, then we'll just add 1.data. Resulted, add last 1.data. We'll move our 1 to 1.next. And if our 2 is not equals to null, while 2 is not equals to null, we'll just add resultant dot add last 2.data, and we'll move our 2 at 2.next. Now what we'll do is we'll just return our linked list. Let's try to run this code. And our answer is accepted. Let's submit this. And all our test cases have passed. Now let's just discuss the time complexity of this code. So the time complexity, of this code is ON, because we do this in single traversal. We only traverse all the elements in one traversal. And the space complexity is ON, because we created new link. We created new linked list. That's why the space complexity is ON. So this is the complexities. Time complexity and space complexity both are ON in this question. So thank you for watching this video. I hope you liked it. Please make sure to subscribe to our Pepcoding channel, and I'll see you in the next question.